Hello.
Yeah, by the time he's getting set up,
Clip it as high.
I would like to introduce the next speaker, Professor Bhupen Goswami from ISER, Indian Institute of Science Education Research.
Okay, so I can point to the
Bhupen
side and then laser.
worked with Shukla at Goddard very long time ago, and they know each other quite well. And Bhupen is another leading monsoon researcher. And he retired from Indian Institute of Tropical Meteorology last year. And that is the same institution where Shukla started his career. And in several years that Bhupen was at the director of IITM, he brought revolutionary changes and made it into a leading research institution in India on monsoon. So today, Bhupen is going to talk about Beyond ENSO, exploring new source of seasonal monsoon predictability.
Thank you, Krishna, and thank you, Zim, for inviting me. This is a wonderful occasion, and Shukla is a dear friend, and I have taken special pain to come here and be present in this wonderful occasion. So, I think I have been very fortunate to be associated with two remarkable people, and Julchani and Jagdish Shukla. In fact, like Shukla serendipitously met Chani in Japan, I met Chani in New Delhi in 1976. There was the IUCG conference, and he invited me to come as a postdoc to MIT. He introduced me to Shukla. Shukla introduced me to Krishna, and that started a very great personal and professional association with Shukla, which I value very dearly. So people have talked about Shukla's contribution to science and so on and so forth, but personally I feel Shukla is a great person and is a great friend, and I think he goes out of the way to help his friends. So I have always respected Shukla's vision and optimism, and that has inspired me throughout my own career. And until 2006, our association were always basically mostly academic. But in 2006, I took over as director of the Indian Institute of Tropical Meteorology. And that was an opportunity when the new Ministry of Earth Sciences also started. And Shukla became the chair of the advisory panel. And I started thinking about contributing seriously to some of his vision to improve or take the Indian weather and climate prediction system to a state-of-the-art level. And there, of course, there are a lot of challenges. Shukla has seen that over the last several decades. He has been trying. But I think this provided an opportunity where we work together, and I put a lot of effort to change two things. One is, of course, we needed to have enough people to do modeling efforts in India, which was missing, and so we needed training. The other thing was the computer resources were very poor, so we needed to upgrade that. So we worked on both these effects, and we started what is called Monsoon Mission. And under this, we were able to mobilize certain funds and training programs. So as a result, I think we have been able to set up in India now today, or convince also IMD to go to the numerical weather predictions on high resolution numerical weather predictions, set up a seasonal prediction system at IITM and extended range prediction system at IITM, and take it to even develop a model for or being able to do climate change predictions. So I think there has been considerable improvement in the status of Indian weather prediction systems. Of course, this is quite a quantum jump. Of course, there is still a lot to be done. And now that I have retired, I think Shukla, your overall, pushing will be required to even sustain this. I think this is going to be a big challenge for us. So, I think Shukla, thank you very much for your vision and optimism through which has driven to achieve some of these. So. What I'm going to talk today is a work based on my colleague who has mostly done this work, and the paper has just appeared in climate in QGRMS. So there is a very simple idea. So for a long time we have been, I think, thinking about monsoon predictability coming mainly from ENSO. and tropical sea surface temperatures. But we know that the ENSO-monsoon relationship explains only about 40% of its, maximum 40% of its variability. And the predictable variability of monsoon may be about 60%. So about this 20% of the variability comes from somewhere we don't know, we have not been able to explain. And monsoon prediction has remained as a challenging problem, and unless we are able to identify where this predictability comes from, we will not be able to capture that in the prediction model. So what we have been able to try to see is that apart from tropical SST, we have been able to show that extratropical SST in the North Atlantic and North Pacific can also contribute to the predictability of the monsoon. And we have demonstrated by using a simple, very simple analysis and model experiments that this is an additional source of predictability which can be harvested. So the predictability of course, the basis for scientific basis for predictability was Chinese and Shukla's, of course, pioneering work. However, the monsoon remained a grand challenge for predicting the monsoon remained a grand challenge, and the Asian monsoon, the correlation between predictions and observations remained very poor. And this partly probably due to the fact that the external forcing or the predictable component and the climate noise are comparable in this region. So therefore, it is very important that we identify what are the predictable component and try to harvest that in the models. So as I said, the correlation between monsoon and El Nino or ENSO explains only about at the most about 40% of the variability. And if you do understand that ENSO is an important component because you understand how it affects the monsoon in various different ways. One of the ways it affects is through this tropospheric temperature gradient. It affects this, it sets up stationary waves and it affects the tropospheric temperature gradient in this region and affects the onset and withdrawal of the monsoon, thereby affecting the length of the rainy season and the monsoon. So we know the dynamics, but it still explains only a certain amount of variance. And if you look at the monsoon and the relationship in some detail, you see that some of these droughts are related to the El Nino, and some of the flooding events are related to the La Nina. However, there are many strong monsoons are not related to El Nino. Many very weak monsoons are not related to El Nino. And there must be some other drivers that if we can identify some drivers for some of these areas, then in this area, what are the factors that drives monsoon in those years, then we may be able to actually identify new sources of predictability. And that has been the idea behind this work. And this started essentially from, actually, we were inspired by 2013, and in the routine prediction experiments, the seasonal predictions, we found that the model, the CFS model predicted it quite well. But looking at the sea surface temperature anomalies during that particular year, it looked very clearly that the tropical SSTs were very weak, but the extratropical SST patterns were quite robust and strong. And then we looked at how it affects the seasonal cycle of the rainfall, and sort of the seasonal cycle of the rainfall was elevated, and the tropospheric temperature gradient was strong in this region. So it added to the strengthening of the monsoon. So we made a hypothesis that 2013 is essentially driven by the extratropical SST. So that was the basic point, and we proved that by doing several GCM experiments and giving these the sea surface temperature anomaly, and indeed showed the GCM experiments indicated that the success of this forecast experiment was essentially due to the success of the model predicting the correct SST, and that SST responding correctly to drive the monsoon rainfall to the positive side. So these various several experiments were carried out, and it indicated that the most of the tropospheric temperature gradient that essentially arose due to the extratropical SST, not the tropical SST. So that was, and also we did a simple the prediction experiment also by removing the coupling beyond the 15 degrees north, 15 degrees north, and 15 degrees south, so if you substitute the SST to the north by climatology and don't have these anomalies, essentially model will actually predict a drought condition during that year. So it supported the hypothesis that probably the 2013 monsoon was indeed driven by extratropical SST anomalies. If that is so, is there other examples of that that kind of a situation in the history? So we went back and looked at historical data and looked at whether there are some conditions where the tropical SST anomalies were weak, sort of it was going through transition phase, and extratropical SSTs were strong. So we could find out several such years actually, about 6 or 7 such years, and in fact, if you do a composite of that, that showed this kind of an interesting pattern of extratropical SST, strong extratropical SST anomalies. There is a tripole pattern here, there is a strong pattern here. And of course, it is very different from normal La Nina kind of, La Nina also has some extratropical SST, the pattern is quite different. And so it is a unique pattern of SST, extratropical SST, which can drive the above normal condition of monsoon over India. So this is the with that we developed the hypothesis and looked for further. So it said that. So there are sometimes the extratropical SST can be strong and the equatorial SST can be weak, and then it can have an influence on the monsoon. Now, how is that happen? So to do that, how does that pattern arises? To see that, we looked at basically the tropical mode of variability. So you identify the ENSO mode by using an EOF and so on, and then extratropical mode. But this extratropical mode we did using both the basins, and so this essentially shows that this is a dominant pattern, is a sort of interdecadal or a decadal component. Of course, superimposed on that there is a certain amount of interannual component, but main dominant pattern is the interdecadal component. So there is this two different modes which can superimpose and produce such a pattern. So the way we try to do is that once you have this interdecadal mode, you try to find out positive side of the interdecadal mode, mode and one standard deviation. Then look at when the tropical mode is within plus minus 0.5 standard deviation, so that it is in the transition phase. And then you do find out which years are those, and then you go back and do a composite. So you can identify a pattern which can give rise to positive rainfall anomaly over India. So this we identified a pattern like that. Then we asked whether an opposite case is also possible. Like suppose in the negative phase of the interdecadal mode, and again in the transition phase of the for the tropical mode, whether the opposite thing happens, whether the monsoon is weakened. So for that we did the opposite thing and we found a different pattern. So we did a composite of with the first PC of the standard interdecadal mode, and again the ENSO mode being within the normal range of 0.5 plus minus 0.5, and monsoon being negative. So if you use those criteria, and you can select about 6 or 7 years like that happens within this 100-year period, and that will give you a pattern which is different. This pattern is somewhat complementary. I don't have a very clear idea of how they are related, but they are different, and the response of these two patterns to monsoon is different. So how does it influence the monsoon? Of course, there are several theories that people have looked at, how the SST over the extratropical. Krishna has done a good deal of work on this. We did a little bit of work earlier, and we showed that that especially the AMO or this particular mode is quite related to the AMO. And under the AMO, we can show that it changes the jet streams and the NAO frequency in such a way that it sets up a tropospheric temperature anomaly in this region, in one phase to strengthen the monsoon, in another phase to persistently weaken the monsoon. So with that, so we know that then several modeling experiments have been also made to test this hypothesis, and therefore there is a basis to see how it actually influences. So having these two patterns, then we asked, we took an atmospheric GCM and asked whether, okay, these two patterns, does it respond and then produces positive anomaly, strengthening of the monsoon in one case and the weakening of the other case, and indeed, it does, and so it substantiates the sort of hypothesis, that there is a certain pattern of extratropical SST anomalies which can influence the monsoon. In one pattern, can influence the monsoon to become above normal. In another pattern, it can produce make the monsoon below normal. So therefore, I think this provides a basis to explore and exploit that the extratropical SST effect on the monsoon prediction. And I hope that what seems to happen is that if you look at how this affects the monsoon, they also can the model response indicates that they do produce the desired type of tropospheric temperature gradients in this region. So I think the good thing is that some of the models are now able to capture these, predict these extratropical SST anomalies about the season in advance with reasonable skill. So therefore, that provides also a basis that we can exploit these for improving the monsoon prediction. So with that, I think I'll stop.
Thank you, Bhupen.
Thank you. Nice piece of work. You concentrate, of course, on the Indian summer monsoon for very good reason. I've mentioned many times to Shukla that India isn't a very big place in the context of the whole tropics. Bin Wang showed some results yesterday, some joint work we've done, which shows that when you consider the global tropics, there are associations. I wonder if you were to extend the, as the global monsoon is correlated, India to Africa to whatever,
right.
I wonder if you were to enlarge your precipitation domain, if you would find similar influences of high latitude sea surface temperature.
I would imagine so. We haven't done that yet, but I think I'm quite sure that we will get. Yeah.
Any other question? I have a question.
Yeah.
So this ENSO-monsoon relation, does it get modulated on a decadal time scale, or are there some years when there is a suppression of that ENSO effect on monsoon due to this extratropics, or an enhancement?
The way I believe is that when the ENSO signal is strong and the SST anomaly in the tropical region is strong, the tropical teleconnection dominates. And on the other hand, when it is kind of transition phase and the SST anomalies in the tropics are very reasonably, quite weak, in that case, the extratropical effects can influence the monsoon. Otherwise, their effect is relatively strong, relatively weak compared to the dominant effect of the equatorial teleconnection through which the El Nino affects.
Right. Okay. Okay. Thank you, Bhupen. Thank you again.